Hey guys, in this video we're gonna continue from the previous videos and finish all of our pseudo ops or directives that we have left. So stick around for that one. Okay, so now let's go through the rest of the directives. Let me see properly. So let me bring me a count. So we have align program counter. So if I go over here somewhere, it should be a line over here, and we're gonna pretty much align the PC counter within bytes boundary, and you're gonna fill all those aligned values of whatever you want. So let's say 112 bytes and give it a value, I don't know, 5. For to compile this, come over here and debug. Oh, actually let me put over here right after 0 over here so it's easier for me to see. Here it is. So we are 512 bytes, we're gonna put in the value 5 over here, all these values. Well, it's good if you remember, like, some instructions takes either from 1 byte to 3 bytes. Some takes the operand by itself, like the NOP operation, and other like the store and some absolute path. So you got the store the value, so the operand, and then the 2 values for the location. So for whatever reason your PC counter is off, you can use the align to help you out with that. So let me close this out. That's the line. Next one, have let's go over through all of them. So we have a word over here in the bottom that we use to start a word, which means 2 bytes into our output. So we have a word, and the next one is a long. So this is a byte is 8 bits. Oh, let's make EA. So here is 1 byte. A word is 2 bytes. A long is 2 words. Not to be confused if you could take if you took a higher programming language like C++ or Java, long is a 64-bit. Here is a 32-bit. So there's a bit of difference. Before to compile this, assemble this, it's not a compiler. And EA is an op, so the first one over here is an op. You have 2 more over here, and you have 4 for the long. So just to show you quick, for to comment all of this, should be 1 over here. Perfect. There should be 2. There it is, and the last list should be 4. So we're growing exponentially over here. So those are byte, word, and long. The next one we have is DC. Oh, actually, I'm gonna bring it back. DC over here. If I assemble. Let me comment this out over here. Assemble one more time. See, 1 up, so exactly the same. And if I were to put DCB, if I were to assemble, here it is, the same thing. DC, that by default is B, so DCB is a bit redundant. But if I were to go to the 6502 asm.com, if you remember from our 6502 videos. So until loaded, of course. And for, let's say, the alive, look at this, DCB, declare byte. So that's what we were doing back then. So we have DC .b. Here you can replace word with DC.w. just see .long, so it should be the exact same thing as before, and here it is, the exact same. So next one we have is DS, which is declare space. So declare space is pretty much going to reserve space, and to show you that, let me segment the data, initialize, let me give you a name, variables, let's put an origin over here, the beginning of our RAM space, and let's define space. I'll put sure to make a game, let's say life, and I want to reserve the first byte, DS. Let me bring you guys over here. Did I go through, guys? Okay, DC declare data in current segment. No output generated is .u. DS declare space. No generated new, and you see over here our expression over here says 1, 2, and 4. So a byte, a word, or a long. So here, DS.1. Oh, where am I? Oh, I have Visual Studio open for whatever reason. Get out of it. So give me a 1 byte of space. And actually, just to show you guys, let's have something called points. Give me 2 bytes. I mean, give me a word or 2 bytes. Give me a life. So define space 1. I want 1 space over here. If you go VS, here it is saving the space for vsync. It's reblank, so we're doing the same thing over here. And here you're putting some values. So let me load A again with a value 4. Then start what's some value A in points. And then start what's a value A in life. So if we're to compile, assemble, keep saying mix it up. Here we have start at RAM location 80. It's right over here. It takes 2 bytes raw word, as you see. That's why 80 and 81. And then the next one is gonna save 1 space for me for life. That's 4 over here. And that's the DS define space. So now go back. Next one, DV, declare value. Like I said before, this one is a mystery. It says the equivalent to DC, so it's putting a byte over here in your output, but each of your values over here are arguments in the list expressed through a symbolic expression, which is our list over here. So it's passed to that list by the label, EQM label. So I'm just gonna show you that, guys. Well, I don't know how exactly that one works, so I'm gonna skip that one, but that's the gist of it. If you guys know how that works, just let a comment there. If I know how to use it, I'll do another video on it, a quick video. Oops. So that's all the DVs. That one is echo. And echo, since you're over here, let me clear this out. I'm just gonna give it a message to your console over here, like say, hey, I'm here. I'm not here, I'm here. So if you assemble, come to console, all the way in the bottom. So like, hey, I'm here. It's pretty much a way to tell some good way for debugging. So like echo and then expression. Let me go over here. See if I find echo over here. Echo. To expression may also be use the springs or in the screen to this file list right over here. So that's echo. The next one is the ifs. So let me go to if, else, and if. Okay. if actually, let me skip this one to go to the variables. How to do that? What's the another one? And macro. I'm gonna do macros in different videos, but that's how you define a macro in the macros. And so let's skip that one. If content is defined, if it's not defined. EQM define macro, and EQU set equate. So let's go to the EQM, which is gonna set as a string or in our table over there. Let me see if I can find it. EQM, the string represented with expressions assigned to the symbols, and this is our symbols over here. And occurrence later expression called the string should be evaluated to the occurrence, also using conjunction of dv pseudo ops. So if I were to, let's give it a label, test EQM, and then whatever you're going to put over here is going to be a string. So if I were to, you still can do something like this, like load test, still works. So if I were to assemble this, load, it's load 3. So this is loading 3. Let me go to the console over here, and if you see this in alphabetical order, here is our symbol test. So this is a string EQM, S represents string, and here you have a 3 in value string. So load, what's the memory location 3, or I can put a pound over here to mean literal. So load 3, so load 3 to the v blank. So that's what this EQM is, set a string value to our symbols over here. And the next that we have is EQU. Oh, tap EQU. So if I were to assemble, you see it happened the exact same behavior, but this time it's not a string. If I were to test, no, go to the bottom. It's another list over here. Test, as you see, it's the value 0, 3. And this R means this reference, meaning it's being used by our code. You see all of this that doesn't have an R is not being used right at the moment, at least. So when this file was assembled, so R, I'm using it. If I don't use it, let me clean the file over here. Let me change it to ww2 since be the last thing. Console ww not being used, so there's no R over here. Clean this up. So that's the EQU is assigned to the symbol, as you see over here. So that's in another way. Instead of doing EQU, you can just put an equal sign, pretty much like a variable. So assign the variable 3. So let's load a ww, assemble, array 3, exact same thing. So pretty much like a variable. So you're gonna have a list when this file is assembled inside a binary, and it's gonna reference this. So since you have ww over here, let's go back to the ifs. So let's say if ww equals 2, echo 2, else echo 3, and you have the and if. So apparently I have multiples and if. So and if. So for to compile this with your console, let me clean this up and just do it again. At the bottom, 3, because it's it's not a 2, it's a 3. If I put a 2, assemble, should say 2, 2. Of course, it's a if, else, and if. So if make sure your logic's right. So this should be 3, 3. So that's our if, else, and if. If you come from a higher programming language, you should know what those are. So okay, you have your ifs. Actually, let me go. No code is going to be generated since it's all compiled, so since it's all assembler specific. So never mind on that one. So the next one we have is which one? Else and the assembly. I'm being that and if EQM and assembler for error. So that's something happens. Some code, some misbehavior happen. You can end the program right away, like abort assembly, and fix that. What's the next one? Hex. Declare. It's pretty much like byte, but this one is hex. So I can go indefinitely. So I'm putting a hex value over here. So if you come over here, where's X? This sets down Rex data. Spaces are options between bytes. No expressions are allowed. Note, you do not place the in front of the digits. Oh, okay. That's why it's complaining over here. Oh, no errors. Oh, here it is, a bunch of ops. Just hex and all those values. Alright. Hex is done. What's that after hex? If content is defined. If content is not defined. So it's pretty much test equals 1 if constant and if. So if you come here to document down here somewhere, if it's true, the expression result is defined false. So if constant test echo, I don't know, works or something. Oh, actually going to console. Oh, it's work, it's defined. There is no test. Let's go to console. It didn't work, so there's no echo. And of course, since we had if defined, you have if not defined, exact same thing. Then you have our include binary file, so we're including another binary file into your code. Let me go to the documentation, goes a bit further, include another literal output. Yeah, and have include the directory. So if I were to include directory right over here. For to include directory of this, let's see if that's gonna work. I'm not sure. So let's see DASM machines 3600. So I could do something like this, I believe, and then include those two. So let me try it out. I'm not sure if that's gonna work, but let me try it out. I sure want to delete those. Yes, delete those. Yes. Let me see if that's gonna work. As you see, it worked. So I included the directory for the two items over here. Let me bring those back to over here. Let's copy. So you could do that. Include directory. Okay. Sorry for the edit. Had to do something. So let me finish this off really fast. First, we have the listing. This one I'm not really sure. It says turn on and off listing. If you go to the documentation somewhere over here, it says globally turns listening on and off. Start with the current line. It's really vague. The only thing I can see listening over here is probably the symbol list. Not really sure on this one. If I find out, I'll most likely make another video with the directive I'm not even sure about. Let's see. So that's the list. Long macros are gonna go over later. We have relocate the orange end, relocatable orange end, and if you come over here, if I can find it, Control F this. Up. Deactivate and relocate the orange to the current segment. So pretty much this is the orange, so it's gonna deactivate and relocate to the orange of the current segment. So if we're over here, we're gonna deactivate this part and gonna go back over here and generate with this as reference. So that's the RN. We have the relocatable origin. You can relocate the origin. If I can find it, right over here. Just activate and relocate the origin, pretty much like the name itself says. Just to quick finish this off, since it's already getting way too long time. We have, let's see, segment U, set. So this is used with the macro. Here you have like sleep, give me an amount of sleep, that's this one is here. And then we're setting that to this temporarily label. So as soon as you put a dot over here plus the label name, it's temporary. So set 1 2 cycles. What else have we over here? Subroutine. It's pretty much a boundaries between labels. I'm correct then? Let's see. It's not really a subroutine, but a boundary between sets of temporary labels. So you'll see it's almost let's really explain subroutine first. It's almost the exact same thing as you see over here. So yeah, I'll probably do subroutine for macros first. So jump over here, branch to 1, etc. branch to QQ, etc. Just like I said, it's a boundary between sets of temporary labels. Boop. And is there anything else over here? So DV, which one? DV, the list, not really sure. And pretty much think I cover most of it, not all. Some of you I'm not really sure about, but like I said, I'd probably make another video to finish those if I get some examples of how that works. Sometimes this wording over here, it's not necessarily our fault, but some examples would be nice. Like example, boop. Sometimes that would be nice. But that's gonna be it for this video. I know this is probably 30 plus minutes. In the next video, I'm probably gonna be over the macros and what they're useful for. So thanks for your time and thanks for watching. See you in the next one.